Welcome to Brain Vision.
So if we want to find the surface area, we can just go ahead and use this equation here. Now the first thing I'm going to do is just go ahead and figure out what our partials are with respect to x and y, and then we can use this part that this is being trapped on the inside to find our projection into the xy coordinate plane. So let me go ahead and scoot this down. So first we go ahead and solve for z. So we would just subtract everything over and then divide by 3. So that's going to be z is equal to 1 minus x minus 2y all over 3. Now, if we take the partials of this, so first the partial with respect to x is going to be, well, everything else in the numerator is a constant except for negative x. That would be del z by del x is equal to negative 1/3. And then if we do the same thing with the partial with respect to y, now everything other than negative 2y we assume is a constant. So that would just leave us with del z by del y is equal to, it looks like negative 2/3. So first let's just go ahead and plug this in to our equation really quickly. So we have this boundary D, which essentially is just going to be, I guess, this over here, this cylinder, because if we project a cylinder into the xy plane, then it's just a circle, which is what we have there essentially. Now we just need to plug these in, so it would be the square root of 1 plus, okay, so we square 1/3, so it'd be 1/9 square 2/3, or negative 1/3 and negative 2/3. We get 4/9 dA. And then we can go ahead and add all of these up. So that would be 5/9 plus 1, which should be 14/9 dA. And then actually, if we just distribute the square root, that would give us, let's go ahead and do that in one step here. It'd be root 14 over 3. Right, so now at this point, there's two things we can do. Since this is supposed to be our region D over here, and we're entering just a constant, we're essentially just finding the area of this region here and then multiplying it by our constant to find the volume. So I'll kind of do that off on the side here. And if you don't like doing it this way, then I'll show you the more rigorous way where we kind of put this into polar coordinates and all that. But yeah, so if we were to go about doing it that way, this is going to be root 14 over 3. And then, well, the area of this, since this is supposed to be a circle of radius square root of 3, because remember this is supposed to be equal to r squared, then this is just going to be, well, pi r squared since it's a circle. And, well, r squared is just going to be 3, so it would be pi times 3, or 3 pi. So we could just come over here and do that. So it would be pi times 3. Notice those 3's cancel out. And we're just going to be left with pi root 14. So, I mean, this is the answer, and I would just go ahead and do it this way. So you don't have to do more work than you really need to, but if for some reason you need to be a little bit more rigorous, I'll show you how to do that as well. Yes, so now if we want to describe this region, so again, I'll kind of just draw it out right here. So we have this circle, and we already know this is a root 3 radius, which would then mean, if we were to write this out, it would have where our radius goes from 0 to root 3, and then our rotation theta, well, we just rotate all the way around, so it would be 0 to 2 pi. So we can come over here and write all that in. So we do theta on the outside, so it would be 0 to 2 pi. Then we have 0 root 3. And then the root 14 over 3 stays there. And then remember this dA, this is going to become r dr d theta. And it's important you put that r there, otherwise you just get bad answers. Yeah, so let's go ahead and integrate this now. So on the inside, this is just going to be power rule. So it would be root 14 over 6 r squared evaluated from 0 to root 3. And then if we were to go ahead and plug root 3 in, well, we'd square that 3, and then the 6 would just simplify down to a half. So this is going to be 0 to 2 pi of root 14 over 2 d theta. And then if we evaluate just a constant from 0 to any number, we just multiply by the upper bound. So this is just going to end up being root 14 over 2 times 2 pi, which 2's cancel out, and you can see we get the same thing, but just doing it a little bit more rigorously. But yeah, so again, I personally would prefer to just use the fact that if we're integrating a constant, we know we're just finding the volume of some object that is like a box in some sense. So it would just be area of the base times whatever the height of it is. Yeah, so just kind of depends on which way you feel more comfortable going about it. But you can see we get the same answer regardless.